The previous example illustrated how APPL's list of lists format can be used to define a discrete random variable. This example shows how the APPL list of lists format can be used to define a continuous random variable. Let x have probability density function. F of x is equal to x over 2, and that's defined on the support 0 is less than x is less than 2. The three things we would like to find here are, first of all, the cumulative distribution function capital F of x. Then we want to find the probability that x is greater than 1. And finally, we'll calculate the quartiles of the distribution of x, namely the 25th percentile, 50th percentile, and 75th percentile of this distribution. Here is the APPL code, and the APPL code contains 6 lines, the first of which establishes the random variable x. This uses the list of lists format. In the first sublist, you see x equals x over 2. This is Maple's format for defining a function, and x over 2 is little f of x. The next sublist contains 0 and 2, and those are the endpoints of the support of the random variable x. The third sublist contains 2 strings. The first string is continuous with a capital C, and that tells you that you have a continuous random variable, and you know that because of the support. The next string is PDF, which stands for probability density function in double quotes. All that tells you is that this x over 2 here is a probability density function and not something else. So the first thing we do is we want the CDF of x, and when you do that, that will return capital F of x. And capital F of x in this case is 0 for x less than or equal to 0. It is x squared over 4 between 0 and 2, and it is 1 for x values greater than 2. The next thing we want is the probability x is greater than 1. That is 1 minus the CDF of x evaluated at 1, and that will be calculated right here as 3/4. Finally, these last 3 statements here, IDF of x evaluated at 0.25, 0.5, and 0.75 will give you the 25th percentile, 50th percentile, and 75th percentile of the distribution. We have seen these before. Of course, this middle one here is the population median.